Then I'll give you guys time to, double check your answers for all the odd number questions, or if you had a question on the odd number questions, you guys can check the video. Then that way, here's the thing, you guys can always check the video at home for all the odd numbered questions. So if you have an even numbered question, that would be one that you would want to ask in class, right? Okay, ratios and proportions is going to be super important as we lead into slope, equations of lines, and as you start to do more stuff in Dr. Getman's class, okay? So a ratio just compares two things together like miles per hour. You guys all had to run for Hagen today, so your miles per hour might have been a little slower because it's hot. But ratios can be written in words, like 1 to 5. You can use a colon, or you can use it as a fraction. Okay. I do want you guys to reduce things. When you set up ratio and proportions, you set up common units over common units. Meaning, if I had 12 red cards and 20 green cards, I'd have 12 red over 20 green. And then that's the ratio of red cards to green cards. It's just a fraction. I do want you guys to reduce the fractions. So they're both divisible by 4. So that means 3 red cards for 5 green cards. And all we're doing is a little, turning words basically into fractions. Okay. We will solve for different ratios tomorrow when we call it proportions. Okay. So in Jack's class, there's 18 students that are tall and 10 that are short. In Michael's class, there's 54 students that are tall and 30 students that are short. Which class has a higher ratio? This is why we did the fraction war. 18 tall versus 10 short. Or, and this was in Jack's class, or in Michael's class, you have 54 tall to 30 short. To compare ratios, there's a couple things you can do. One, you can reduce and then try to compare them. Okay? Or two, what I notice is 30 can be the same thing as 10 times 3. So I can find, just like what you guys did when we did the fraction war thing, I can multiply the top and bottom by 3 and then compare the numerators. So then that's the same thing as 54 tall, right, to 30 short. And they're the same. They're the same ratio. Which you could have figured out by reducing them. But in a sense, when they had different denominators, what I would do is try to make them have a common denominator and then compare the numerators together. Any questions about your ratios and proportions? Yeah, Grant. They are the same ratio. Yes, Jordan. What is a rate? Yeah. Like miles per hour. Oh, this rate? Like express the like 7 batteries cost $12. Oh, you're on the homework. We're not there yet. Questions about the notes? Yes. Correct. And in this case, because they were both 54, then they were the same. Yes. You would have put which one's higher. If they were both not 54, then whichever one's higher. Other questions that you guys have? Do not forget that your group quiz is on Thursday. This Thursday, like it is in 2 days. Okay, so we'll talk about that in just 1 second. To Jordan's question, because he asked about the problem set. When you start to look at the problem set, and I did these on the video. When I want the rate, I want like per battery, how much does it cost? Or how much money do you get if you mow 1 yard? That's what I'm actually looking for. I don't care about you getting a decimal because I told you before I want everything in improper fraction form. So I'm okay with you guys leaving it at $15 over 4 because you can't really reduce that. I'm okay with you leaving that because really what I'm testing on is, can you express this as a fraction, the words as a fraction, okay? And that's really what I'm looking